Hello, welcome dear students. So now we will discuss about pressure in fluids. But what do you mean by fluids? The substances which don't have any definite shape and size and that can flow are called fluids. So among solid, liquid and gases, solids have definite shape and size and they cannot flow because of their high rigidity and extremely less compressibility. So solid cannot be fluid. But both liquid and gas both have no definite shape and size and both can flow. So that's why liquid and gas simultaneously both are called fluid. But in between liquid and gas, the compressibility of gas is extremely high than that of liquid. The compressibility of liquid is slightly greater than that of solid but less than that of gas. Okay. So gas can flow in all directions, whereas liquid cannot flow in all directions. Okay, because of its slightly less compressibility than that of gas, and also that is because of some intermolecular gaps or space and intermolecular forces. Since the intermolecular space in case of liquid is less than that of gas, so intermolecular forces between the molecules of liquid is much greater than that of gas, so that's why gas can easily flow in all directions, whereas liquid cannot. So how fluids exert pressure? Now in case of solid, we have seen that solid exerts pressure only due to its weight. Okay. Now whenever any solid object is placed over any surface, it exerts pressure only on the surface, that is on the contact between the solid surface, okay, the surface which it touches, it only exerts pressure only on that surface where it is placed. So since weight of a solid is always acts in the downward direction, so that's why solid objects always exerts pressure at the bottom of the surface where it is kept, that is at the bottom in the downward direction. But unlike solids, in case of fluids, that is liquid and gas, they exert pressure at the bottom as well as to the boundary wall, to the boundary wall or the wall of the container in which it is kept, due to their tendency of flowing. Clear? Now since liquid has greater weight than that of gases, isn't it? Since an intermolecular space is less and the compressibility is less than that of gas, so the pressure exerted by liquid is much greater than that of gas. So that's why gas can flow in all directions because of its high compressibility, isn't it? Greater intermolecular force, greater intermolecular space and less intermolecular force between the molecules. So it means the rigidity of liquid is slightly greater than that of gas. So the pressure exerted by liquid is slightly greater than that of gas. But both can exert pressure due to their weight as well as to the wall of the container in which they are placed, because liquid experiences gravitational pull, isn't it, by the earth. So that's why water generally liquid such as water generally rolls from up to down, okay, from above to ground surface, whereas gas can spread in all directions, towards right, towards left and above at the same time simultaneously, whereas liquid cannot, either from high to low, or from left side to right side, or from right side to left side. Okay. So now let's see the mathematical expression of the pressure exerted by any liquid. Okay. So now suppose there is a vessel which contains some liquid. It may be water or any oil or whatsoever. Suppose water, okay. So inside the vessel it contains some water and we want to find out, determine the pressure at a particular point inside the liquid. Look, the liquid is stationary. So inside the pressure exerted by a stationary liquid. So inside the liquid we want to determine the pressure at the particular point C, at the particular point, this point O, which is at O, inside the liquid, okay, which is at a depth h from the above surface. So now if we imagine a cylindrical column of water, isn't it? Now we consider a water column, a cylindrical water column A, B, C, D. Okay, where the height of this water column is h from the free surface of the water. Okay, and its surface area of this imaginary water column or the cylindrical water column is A. Clear? So the height of the liquid column is h. H is from free surface. Always remember always the height of a liquid column or any point inside the liquid is measured from its free surface, not from the bottom. So the height of the liquid column, or we may say the point, okay, because around the point we have imagined a cylindrical water column. So height is h from free surface, surface area is equals to A. So obviously, and the density of the liquid is rho. Clear? Now the thrust or the force exerted by liquid column on the plane, as we have learned that solid exerts pressure due to its weight on the surface, and liquid both on its bottom due to its weight as well as on the boundary of the well. So since this is a water column, so it will exert a force on its surface, isn't it? That is the surface CD, isn't it? Or you can say plane, on plane CD, or the cylindrical or the circular surface CD, or the plane CD. So it obviously has some weight. So due to its weight, it will exert some thrust or force on the surface or the plane CD. What is called? This is called thrust, and which is nothing by its weight. Due to its weight of the column, which is nothing but weight of the liquid column, which is W is equal to mg. Now what is the mass? Now mass is equal to volume into density. M is equal to dV. So volume of the entire liquid column into density of the liquid into g. G is the acceleration due to gravity, which is constant at a particular place. So now what is the volume of the liquid? Now volume equals to area into length, isn't it? So now volume of this liquid column ABCD equals to area of this liquid column into its height. So what is its area? We have already assumed that is A, and height is h, and then density of the liquid, which is already rho, into g. So now this is the thrust or the force which is exerted by the liquid column on the surface CD. Now we will find out the pressure. So we have already learned the pressure exerted by liquid column, that is force per unit area or thrust per unit area. So AH rho g divided by A, this is H rho g. So the general expression of liquid pressure, the pressure of a liquid exerted at a particular point inside the liquid, is H rho g. But this is not the total pressure exerted by the liquid, because above the free surface of the liquid there is air, that is atmospheric pressure. So this air will obviously exert some pressure on it, on the liquid surface, so which is called atmospheric pressure. So this will be added to this expression. So the total pressure exerted on this water column or exerted by the liquid is equal to P total. P is equal to atmospheric pressure plus P, which is P0 plus H rho g. Clear? Now from this expression we can clearly see the affecting factors of the pressure exerted by liquid. That is, P is directly proportional to H. It means pressure is directly proportional to the height or the depth of the liquid from its free surface. More will be the depth from its free surface. Depth means height from the free surface, more will be pressure. So it means inside a particular liquid, if we consider 2 points, the point which is at a more depth, at that point the pressure of the liquid is more. That can be easily demonstrated through a very simple example. You can see there is a cylindrical vessel and it contains some water, and we have just made 3 holes in it. So you can see from the point at the extremely top, the water will flow and it traverses small distance, whereas the water which emits from the middle hole, it traverses slightly greater distance, whereas the point which is at the extremely bottom, isn't it, the water after emitting from it travels a longer distance, because pressure is directly proportional to the depth, the height of the liquid column from its free surface. Now the height of the liquid surface, isn't it, you can see from free surface is extremely less. So the velocity, since pressure is low, so velocity is very low. So since velocity of the amount of water which releases from that hole it will traverse a small distance due to its less velocity. Whereas now if we gradually goes down to the second aperture, isn't it? So its height is slightly greater than that of the water releases from upper hole. So its velocity is slightly greater, means the pressure is slightly greater than that of the above hole. So that's why it traverses a longer distance. Whereas at the bottom, among these two holes, the water at this level contains the maximum height, that is the depth is maximum. So that's why the pressure is huge. So the water releases from this hole as the maximum pressure. So that's why the velocity of the water releases from this hole will be maximum. So that's why it traverses the maximum distance. Clear? Now that is a very easy example also. That is that in case of the water supplement system in a big city or in our house, generally water tank is placed at the top. Why? Now since water tank, more will be the height, more will be the depth of the water. Okay. So generally it has been seen at the ground level, the force of the water is immense, isn't it? Since in case of ground floor, in case of tap, if we open tap at the ground floor, now the height of that particular water from the above is more, so the pressure is immense. So due to larger velocity, the maximum amount of water is generally released in a very small period of time, and it takes a very less time to fill the bucket. Now if we gradually move in the upward direction, that is in the first floor or the second floor, so the depth, height from the free surface decreases, so the pressure of water at the tap, isn't it? So the pressure of water at the first floor or the second floor gradually decreases. So pressure becomes very less and the water emerges with a very slow rate. Clear? So this is the pressure of the liquid, and also that is the density, isn't it? So this is the first apparently factor, height. Clear? And again there is generally the bottom, isn't it? At the bottom, in case of a dam, the wall of a dam is generally made thicker at the bottom, because as we have already learned, the pressure exerted by liquid increases with depth. So the pressure at the free surface in case of a dam at the upper level is very less, whereas the pressure of the water at the extremely bottom, it is very immense. So that the dam can tolerate such kind of that immense kind of pressure, the wall of the dam is made generally broader, isn't it? Because at the top height is very less, so the pressure of the water at the top or at the free surface of the dam is very less. As we gradually go to the bottom, the water exerts immense kind of pressure, and if the wall of the dam is not made broader or is not made thicker at the bottom, so it can break easily. So it is made thicker so that it can tolerate that immense amount of pressure. Clear? Then again, generally we have seen when a water bubble releases inside a water in a pond, as it gradually rises in the upward direction, it grows, isn't it? It grows in size, because when it is at the bottom, height is maximum. So since height is maximum, so pressure is maximum, and according to Boyle's law, we have already learned that pressure is inversely proportional to volume. P is proportional to 1 by V. So when any bubble is at the bottom of the water, its height is maximum, so pressure is maximum. So since pressure is maximum, volume is very less, so that's why it is very small in size. As it gradually moves in the upward direction, it grows in size, because as it gradually moves in the upward direction, height decreases, so pressure also decreases. So since pressure decreases, volume also rises. So that's why when a water bubble moves in the upward direction, it generally grows in size. There are so many other examples. Now number two is pressure also depends on the density of the liquid. It means the liquid which you are taking, it depends on the density. Okay, more will be the density of the liquid, more will be the pressure. Now if you take water, it will exert definite amount of pressure. Now if we take mercury, isn't it, or kerosene, or like anything, any liquid whose density is greater than that of water, so the pressure exerted by that liquid will be obviously greater. So these are the affecting factors of the liquid, of the pressure exerted by liquid, any liquid. Now from this we can come to the conclusion of the characteristics or property of the pressure of any liquid. So it means generally that the liquid pressure increases with the increase in depth. It means the height from the free surface, that is the horizontal surface. Next is that in case of a stationary liquid, on the free surface, the pressure exerted by all the points are the same, because the height is the same. Since P is equal to H into rho into G, same liquid, rho is constant, G is constant. So at the free surface, in case of a stationary liquid, all the points, the pressure exerted by liquid at all points on the boundary surface, that's on the free surface, or any particular surface, in a straight line. It may be here, if we draw a straight line here, then all the points, the pressure exerted by all the points is, okay, are all the same, since heights are same. Same depth. Okay, now at a particular, now if we choose any particular point at any particular depth, then since due to its tendency to flow, it exerts pressure in all the same, okay, pressure, the magnitude of the pressure will be same in all directions. Clear? Since it is at the same depth, density is same, G is same. Since due to its tendency to flow, inside, in case of a stationary liquid, inside the liquid, if we choose a particular point, so the pressure exerted by liquid at a particular point inside the liquid is same in all directions. Clear? So the pressure of the liquid increases with the increase of the height from its free surface. More will be depth, more will be its pressure. Because of a stationary liquid, the pressure exerted by liquid at the point of the surface is the same. In case of a particular point, it exerts same pressure in all directions. And in liquid always seeks its own level, means it maintains the same level, to be at the same level. Clear? Now you can see the liquid seeks its own level. We have taken 5 different types and 5 different shapes of containing liquids. Now if we pour water in, okay, pour inside any one of it, after pouring we can see, if we stop, you can see the water, the level of water at all the container or the vessel are in the same level, isn't it? The water will reach in every container containing the same height, as you can see, because this is the liquid seeks its own level. Okay. Now there is a very interesting question that we have seen that whenever we pour any water on any glass or any bucket, we have always seen the horizontal surface is always horizontal. Have you ever seen the free surface of the liquid is curved? Never. Always it's free, isn't it? Always its free surface is always horizontal. Why? Because we all know that water generally moves from, isn't it, flow from a high, isn't it, from an up to down, isn't it, from a high level region to lower level region. Why? Since the pressure exerted by liquid, in case of a liquid, the pressure exerted by liquid at the same height is the same, isn't it? It always wants to maintain the same pressure. It is just like flow of heat from high region to low region to maintain the equilibrium. So the pressure, suppose there are 2 points, a point A and point B. So obviously the height of this point, okay, so this point, okay, so the height you can see, that is it from the bottom, this is H and this is, okay, and this is H1 and this is H2. So this height, isn't it, from bottom the height, this is much more and this is less. So it means the pressure, here the pressure will be much more, and where due to this point the pressure will be much less. But according to the characteristics or property of a pressure of a liquid, it exerts pressure, it exerts the same pressure. So that's why it want to maintain the same pressure. So that's why it flow from upper region to lower region to maintain its equal pressure. So that's why in your practical life, the horizontal surface, the free surface of a liquid is always horizontal. Okay, not a curved surface, because it want to exert the same pressure inside a stationary liquid, isn't it? Inside a stationary liquid, on the free surface, the pressure exerted by liquid at all points are the same. So because of this, liquid always seeks its own level. Clear? And maintaining on this thing, water is generally supplied in a big city. Clear? Hope you have understood. So meet in next video.